From the gear pump, fuel flows through a wire mesh magnetic filter to the inlet or supply passage of the automotive governor. Governor is a speed-sensitive device that automatically controls or limits the engine speed. It does this by varying the fuel delivered to the engine under changing operating conditions. The governor assembly performs three functions: pressure regulation, idle speed governing, maximum speed governing. Let's look at the makeup of the governor assembly. Weight assist spring, weight assist spring shims, weight assist plunger, governor weight carrier, governor flyweight, governor plunger, torque control spring, idle passage, main passage, supply passage, bypass passage, idle spring plunger or button, idle plunger guide, idle spring, governor spring, idle spring seat washer, idle screw retention spring, idle speed adjusting screw, governor shims. In the governor, the flyweights are driven through gears by the fuel pump main shaft. The governor plunger is held between the flyweight feet and rotates with the flyweights. Any rotation creates a tendency for the flyweights to move away from their axis of rotation, which is the center line of the weight carrier shaft. This outward push is known as centrifugal force. The rotating flyweights pivot on the flyweight pins. Through this pivoting action, an axial force is exerted on the governor plunger through the flyweight feet. At any given speed, the position of the governor plunger is determined by the balance between the flyweight force exerted on one end of the governor plunger and the spring force applied to the opposite end of the plunger. The position of the governor plunger is determined by the balance between the flyweight force exerted on one end of the governor plunger and the spring force applied to the opposite end of the plunger. Torque is dependent upon the quantity of fuel that is metered and injected per cycle. In the PT fuel system, at any given speed, torque is dependent on rail pressure. The control of rail pressure in the PT fuel system begins by regulating the fuel pressure supplied to the governor assembly, appropriately called supply pressure. The control of this supply pressure is accomplished through the use of a bypass type pressure regulator. This type of pressure regulator is designed to unseat when a designated supply pressure is reached. For this type of regulator to function, an excess supply of fuel must be delivered to the governor assembly. This ensures that during fuel pump operation, some fuel is always being bypassed, enabling the regulator to maintain control of the supply pressure. When the fuel pressure exerted on the button exceeds the force holding the button and plunger together, the button is unseated and fuel is bypassed to the suction side of the gear pump. The pressure at which the button separates from the governor plunger is determined by dividing the spring force acting on the button by the recessed area of the button. The recessed area or counter bore is the specific area the fuel is pushing against. For a given spring force acting on the button, increasing the recessed area reduces the pressure at which the fuel begins bypassing, thereby lowering the supply pressure. Decreasing the recessed area will have the opposite effect, that is, fuel will begin bypassing at a higher pressure, raising the supply pressure. Changing the recessed area of the button will change the height of the supply pressure curve. A button of a smaller recessed area will raise the supply pressure curve, while a button with a larger recessed area will lower the supply pressure curve. Also, with a given recessed area, any change in plunger position will change the force on the button and change the supply pressure. Increasing speed changes the plunger's position, increasing the force on the button, which raises the supply pressure. It is important to understand that there is a unique supply pressure for each speed. Supply pressure is independent of the flow out of the pump. The regulation of the supply pressure is the first step in controlling the rail pressure. The automotive governor controls idle governed speed and maximum speed by positioning the governor plunger cutoff shoulder over the appropriate fuel passage. Around idle speed, flyweight force is opposed by the idle spring. At speeds close to but below torque peak speed, the flyweight force is opposed by the governor spring. During engine operation between torque peak speed and rated speed, the flyweight force is balanced by the combined spring force of the governor spring and the torque spring. Once the torque spring is engaged, it opposes the flyweight force exerted on the governor plunger. This results in a reduction of the flyweight force, which affects the governor plunger position. The automotive governor controls idle governed speed and maximum speed by positioning the governor plunger cutoff shoulder over the appropriate fuel passage. In governing maximum engine speed, the forces acting to position the governor plunger include the flyweight force working against a combination of the torque spring and the governor spring. The flyweight force acts to close the main fuel passage, while the spring force acts to keep the main fuel passage open. Several items should be noted at this time. The weight assist spring no longer affects the governor plunger position. The idle passage has been closed by the governor plunger. The idle spring no longer affects the governor plunger position as the button has bottomed in the idle plunger guide. When the engine exceeds its rated speed, the governor reduces the fuel supplied to the injectors. The speed at which the governor begins to decrease fuel pressure is called governor brake. Governor brake occurs when the governor plunger cut-off shoulder begins to restrict the main passage. Two other terms often involved in a discussion of maximum engine speed include high idle and governor cut-off. The maximum no-load engine speed is known as high idle. Anytime engine speed exceeds high idle, the main fuel passage is closed by the governor plunger. Governor cut-off occurs at the point at which the main passage is completely closed. The difference in engine speed between rated speed and high idle speed is known as governor droop. It is usually expressed as a percentage of rated speed. Up to this point, we have established some limits for the engine operating range. A supply pressure which is controlled by the pressure regulator incorporated within the governor assembly. A rail pressure which at any given engine speed is the supply pressure minus the total pressure drop across the remaining fuel pump components. Maximum speed, which is limited by controlling the engine power output. This is done by the governor, which controls the rail pressure to the injectors. Within these established limits, the power output can be controlled by the operator through the throttle.